Hi guys, welcome to Think Academy. My name is Zhang Chu, and today we're going to be talking through a masterclass of the nonverbal reasoning paper, specifically on questions to do with nets and cubes. Okay, so let's get started then. So when we're talking about nets, what do we mean? Well, this is the shape that you get if you unfold a cube. And how many different ways are there of doing this? Well, we can see that there's actually lots and lots of different ways, 11 to be exact, which I have broken down into 4 separate sections, okay? So we have one of them, which is called the 141 type, and that has 6 cubes. A second type, which is called the 231, and that has 3 different types. A third one, which we call 33, and the last one, which we call a 222 type. And what you'll notice is that I call it this way because of the difference in the number of faces per row. So here in the first row, all of them are going to have 1 face. The middle row, all of them have 4 faces. And finally, the bottom one also has 1 face, okay? And for the second type, you can see here, there's 2 on the top row, 3 in the middle row, and 1 on the bottom row. And it's the same for 3, 3 top, 3 bottom, and 2, 2, 2, which is 2 in each row. So luckily for non-verbal reasoning, we're only really going to be dealing with the first type of net, which we call a 141, okay? So we only need to care about this section for now. So when we're talking about net questions, typically you'll see that there's 3 different kinds of net questions, okay? The first one is which cube can be made from the given net. So we're trying to find the correct answer, which one of the cubes is possible to be made from the net. The second question is which cube cannot be made from the net. So that means that of the 5 of them, A, B, C, D, E, 4 of them are correct and 1 of them is incorrect. So we need to find the incorrect one. And finally, the third one we need to do in reverse. So we find a cube and then we find a net which can be folded up to make the cube. So you'll see that these 3 types of questions actually are testing the same knowledge point, which is what is the relationship between a net and the cube, okay? And how can we go from between one and the other? So at Think Academy, we've come up with 3 steps. That means that no matter how good your 3D reasoning in your head and your spatial awareness is, you can solve any types of net questions, okay? And these 3 steps are as follows. Number 1, we eliminate the impossible cube. Number 2, we check for opposite faces. And number 3, we're going to transform the nets. Okay, so let's go through these steps together then. The first step we call eliminate the impossible cube. So what do we do here? Well, let's look at an example to help us out. In this net, we see that there are 6 different faces. And the question asks us, are their answers correct or incorrect? And why? So there's one on the left. We can see that the top face is a face which is completely filled in. However, is there a face in our net which is also completely filled in? You'll see that this one doesn't exist in our net. And so that means that this cube cannot be made no matter how you try and fold it. So this is an impossible cube. Let's look at the one in the middle now. So this one in the middle has 2 faces, which are dark circles. And what do we notice about the one on the top? Well, it's only got 1 face, which is a dark circle. So again, there's a face which appears in our cube that doesn't appear in the net. So clearly, this one's also incorrect. Finally, let's look at the one on the right. This one has 1 cross, a black circle, and an arrow. And what do we notice? There's a cross, a circle, and actually there's 2 arrows, so we could choose. So I'm not sure whether this cube is impossible or not, if it's correct or not, sorry. I just know that it's definitely possible. So how should we check in this scenario? I'm going to put a question mark here. Well, we need to go to step 2, which is checking for opposite faces. So what do I mean when I talk about an opposite face then? Well, opposite faces in a cube are the ones which don't touch. So if I draw a cube here, I'm going to call the face on the front face, I'm going to denote it F. And then the front face touches four sides, top, left, right, and the bottom. But which one doesn't it touch? It's the back face. And this one is what we call an opposite face. So we know that the front and the back faces are definitely opposite to each other. And similarly, we can say that the top face and the bottom face are also opposite to each other because they don't touch either. And finally, we have the third set of faces, which is the left face and the right face. So this again is not, they are opposite, so they don't touch. So how do we find opposite faces then in our nets? Well, if I have A and B, and I label them like this, and you'll notice that in this case, I have to have three faces which are next to each other. Then A and B are opposite. I'll write that down. And how can we visualize this? Well, imagine that you pin the face in the middle. And that means A and B, when you fold them, they're going to fold upwards towards each other. So that means that A and B have to be opposite to each other. And we could do a similar thing for this second type. So if we call this one, say, three faces in a row, this one we're going to call a Z face. Okay, so it's almost like a Z shape, which is made of four of them. And again, the opposite faces are A and B. So they occur on the left and the right of the Z. So how do we show this one? Well, again, if we pin this one that I put a dot into, we can see that the B face will fold up. And what's going to happen to the other two? I'm going to fold it up and the A face is going to come around. So I have B on here and A on here. So again, they are opposite. Okay. So to show that in practice, what does this mean? Well, if I have, say, a star, an exclamation mark, and a triangle, and I have a cube, which looks like this, star, triangle, and exclamation mark. Well, from this, I know that the star and the triangle are opposite. And the really important thing to remember is that opposite faces don't touch. But what do I notice in this cube is that the star and the triangle are touching. That means that this cube is not correct. So this is the second thing that we're going to check for all of these questions. So let's put this into practice. So we already know that these two are incorrect. What about the third one then? So in this case, I'm just going to find all the different opposite faces of my cube. I can see here that there are a set of three faces next to each other. That's what we're trying to find. So what does that mean? That means that the circle and the arrow pointing left, these two faces are opposite to each other. Let's find some more then. So I can see another set. If I move this set of blue one across, so I'll do that for you guys. So we're going to highlight these three. They're going to have a cross and a black circle this time. That's the left and the right one of the three faces. And so I know that these ones are also opposite. Finally, I can see that there's three more in the top, which are vertical. And these three, one face is a checkers board or a chess board design. And the other face is a downwards arrow. So again, these three faces are opposite to each other. So if we find them in our cube, that means that that cube must be incorrect. Let's have a look then. So in this third cube, we have a cross, an arrow, and a black circle. So I'm sure you guys have just seen that, hang on, there's a cross and a black circle, but I just told you that they're opposite. That means they can't touch. So that means that this one is also incorrect. Very good. So now let's do some more practice, okay? So which cube can be made from the given net? Circle the correct answer. So let's start with step one. Let's eliminate the impossible cubes, okay? So what do we see here? In A, we have a half filled out circle, a black circle, and a white circle. So they all appear half filled out, black and white. In number B, or letter B, sorry, we have a white circle across and a black circle. So a white circle across and a black circle. So that's okay. How about C then? For C, we have a cross, one circle with lines, and another circle with lines as well. Across, a circle with lines. Oh, it looks like the second face of a circle with lines in it doesn't exist. So that means from step one, we can already eliminate C. Very good. How about then we look at D? So D has a mesh face, a cross face, and a black face. So here we look, we have a mesh face, a cross face, and a black face. So these ones are all okay as well. And finally, we look at E. So E has a half filled in circle, a mesh circle, and a straight line circle. So a half filled in circle, a mesh circle, and a straight line circle. All three of them are there. So by using our first step of eliminating impossible cubes, I've only been able to eliminate letter C. So now let's check for opposite faces then. So to do opposite faces, I'm just going to find all of them in my net and then look for see which ones appear in the answers. Okay, so these ones are opposites to each other. So starting from the top, I have the circle with lines going through it, and I can find that it's the opposite, the one which is meshed. Going down one, I have the circle which is filled in, and I have the circle which is half filled in this time. And finally, I have this white circle and the crossed circle. So these are the opposite faces that I have. Now let's have a look. Do any of these appear to be touching in the cubes which are given as answers? Well, if we look at A, we have a half filled in and a fully filled in circle. And now I can see here that these two faces are meant to be opposite. So that's incorrect. So that means we can cancel out A. How about for B? Well, we have a cross circle and a white circle. And again, these two faces are meant to be opposite. So we can cancel B out as well. How about for E? So I'm going to skip D for now. Let's go to E. E has a half filled in circle and there's no dark circle, so that's okay. But there is a mesh circle and a line and a circle with lines in it. So because these two both appear, they are also classed as opposite. And so that's also incorrect. So then clearly by process of elimination, D must be the correct answer here. So what happens then if by doing these first two steps, we aren't able to solve the question? For example, if there were another face, which we couldn't cancel out using step 1 and step 2. Well, here is when you would have to use the technique of transforming nets. Let me show you how to do that. So before we talk about that, I want to talk about the mechanism behind how to transform a net, and then I'll show you how to use it in a question. So for this, I have two different methods. So the first method is for transforming things along the middle 4 faces of the net. Okay, so the 4 that are slightly outlined in black, those are the 4 which I can transform, sorry. And then the other method is for transforming the face on the left and the face on the right, okay? So there's 2 different methods to transform where in the 1-4-1 net that we are. Well then, let's have a look at how we're going to transform the net in the 4 nets in the middle. So here I have a piece of paper, you can see, and it has A, B, C, and D on it. That's the one we've got printed on the screen. And similarly, I have a second piece of paper, which has B, C, D, and A. Okay, so what happens now if I try to fold them? Imagine I'm folding them into a cube. So except I don't have the side faces, it's see-through. But if I fold them both and I hold both A's towards the ceiling, for example, what do I notice is that the B's are also both facing in the same direction and in the right way. What about if we turn it again? The C's are also facing the same direction and, oops, let go of it. The D's are also in the same direction and facing the same way. But this is really weird, right? Because these two clearly aren't the same. One starts with A and one starts with B. But when I fold them and rotate them, actually, they are the same. So that's a really useful trick that we're going to use when transforming these nets. What we can do is we can take the face at the top and transform it and move it all the way to the bottom, like we've done here. So these two things are the same. And similarly, we can take the front face B and move it down, and you can keep on doing it. And you see that eventually it's going to become a cycle. And what does that mean? So what that means that if I do it, let's do it one more time. C, D, A, B. And one more time after that. D, A, B, and C. So that means that what if I just reverse it? What if I move my bottom one to the top? Well, that's the same as this final one, where I only move the top to the bottom. So what does that mean? It means that I can either move the top to the bottom, or the bottom I can move to the top as well. So that's how we transform the four faces in the middle. Okay. How about then transforming the ones on the left or the right? Well, this one I'm going to demonstrate by only considering one side, because it's actually the same mechanism for both sides. And say I'm going to use an upwards arrow on here. So I'm going to call this in the first position because it's at the top. What if I want to move it into the second position? Well, in this case, I'm just going to have to rotate it once, 90 degrees, so that in this case, the arrow is going to be pointing to the left. And if I want to move it into the third position, I'm going to do the same thing. Just rotate it one more time so that this time it's turning downwards. And finally, I'm sure the quick ones will have already got this, but I can just rotate it once more to put it into the fourth position. Very good. Okay. And now if I want to do it from the right side, then it's actually the same. And I can even go backwards. I can go up instead. So go from the fourth position to the first position. How should I do that? Well, it's still just a 90-degree rotation. Okay, so this time it's going to rotate. So A is going to face towards the four faces. Then A is going to be upside down. And finally, A is going to face away. So I can just keep on rotating this face 90 degrees to move it up and down the four in the middle. Okay, so that's how we move the ones on the side. So let's put this into practice then. So which cube can be made from the given net? Well, in a question like this, I can go through step 1 and step 2 very, very quickly. I can see that in both of them, they're definitely not impossible because all the faces appear on the net. And also that there's no opposite faces which are touching. So I'm not too sure using step 1 and 2 if they're correct or incorrect. Here's what we do for step 3, which uses transforming nets. What we do is we open the net of the cube by what we can see. So this one is going to have a circle in the middle, mesh on the top, and an arrow pointing upwards. And then what we want to do is we want to transform the net on the left so that the circle's in the middle and we can compare whether we can find the net, here I've done it in blue, in the nets which I've transformed. Okay, so let's try that. So if circle is in the middle, and I know that I need an arrow next to it, and I have 2 arrows, so let me just put them both on, because I'm not too sure what orientation they need to be in yet. And let's have a look. Where's the mesh face? Well, the mesh face is up here. So let's move that down using the second method, which is just by rotating it. So luckily, the mesh face doesn't have an orientation. So no matter how we rotate it, it's still going to be just a mesh face. So that's good. Now then, we need to try and find this net in blue in our transformed actual net. If we can find it, that means the answer is correct. If we can't find it, the answer is incorrect. Okay, so what should we do? Well, we can see the mesh is on the top. So let's just rotate our heads and see that the arrow is pointing upwards. So when you rotate this one, we can see that actually, yes, we can find the net in blue inside of the transformed net. So that's good. So that means if I call this one A and B, that means A is correct. So now let's check for B. So in the case of B, if I tried to do the same trick and I tried to open it with the arrow, the light arrow in the middle, I could open it like this. But what I find is in my actual net, there are two separate arrows, aren't there? And that means that I'm not too sure which one should be the one in the center. And I don't want to do more work than I have to. So what should I do? Well, luckily, we can open these nets using whichever face we can see to be the middle. So in this case, I'm going to choose to see the filled in arrow as my middle, which means that still above it is the black square. And this time it's going to be the face on the left, which is the downwards arrow. Okay, so this is the open net, but just looking from a different direction. And again, we can apply the same rules and try to find this net in blue in a transform net with the circle in, with the black arrow in the center. So we have the black arrow. And what do we need to put next to it? Well, we need to put arrows and we need to put the square. So I know there's already one arrow below it, nice and easy. And I can also see that there's a second arrow, which actually does touch the arrow in black. And how do we know this? It's because, remember, when we have 4 in a row, we can move the bottom one and shift it to the top. So I'm going to move this bottom arrow and shift it to be on top of the black arrow. And finally, I just need to move the black square. So the black square is on the right of it. So it's going to rotate up into the first position. And because it's a square, again, the orientation doesn't matter. So we can just do this. So again, now, can we find this net in blue within the transformed net? And what should we do this time? We're going to turn our head the other way. So the arrow is pointing up. But what do we find is that when we do that, the arrow should be pointing away. The non-black arrow should be pointing away. In this case, it's pointing down. So that means that this is incorrect. So when you rotate it, they're not the same. That means B is also incorrect. So that's how we use the third method to work out which one of the cubes can be made from a net. Okie dokie. So now let's put this into practice. So we're going to, first of all, turn this net into a cube and then fill in the missing space on the 3D shape. So what should we do? Well, we are going to open the net first. So it's going to have an arrow pointing left, a black circle to the right of it, and the one that we want is above it. So now let's transform our actual net to be similar to this. So I can see that there's an arrow already, which is already touching a black square. So that means that's the one that I definitely want. And because I'm missing the one on top of it, what should I do? Well, I'm going to take that one on the top and I'm going to rotate it once over so that it's on top of the app. Now then, what should I do? Now then, what should I do? So how should I rotate this? It's going to rotate 90 degrees so that the bottom left and the top right squares are shaded. Okay, and it has to be in this orientation because here it matters. You can see that it's actually different already from the one on the net. So I'm just going to fill it in on this bottom one here as well. Remember, it's just a 90-degree, one single 90-degree rotation. My pen's running out of ink. Okay. How about this one, the second one then? So again, let's open it up. So this time we're going to be pointing to a black circle. And this is also quite difficult to look at because if we look at this one here, again, I'm not too sure which arrow should be in the center. So instead, I'm going to make the black circle my center instead, which makes things a lot easier. So let's again try to find this in our actual net. So if the black circle is in the middle, I can see that the arrow to the left of it is always going to be pointing away from it. So that's not correct. So which one should I move then? It's going to be the face on the bottom. And I'm going to rotate that one through. And it rotates 190 degrees, 290 degrees, so 180 degrees. So it's going to be pointing upwards. And now I'm looking for the shape on the right of it. Which shape is this? Well, I can see there's nothing on the right on the net, but from what I know, I can move a face from the first position to the last position. So that means I can move the circle into that face. So that means the circle is the one which is going to be filling in the missing face. Okay, so let's just do a couple more questions, really just to reiterate all of these methods. So, which cube can be made from the given net? Check cube A and cube B. So in both of them, let's do a very quick check. Are they possible? So we have a bow tie, an arrow, and a cross. That's a tick. And we have a cross, a middle bar, and an arrow. So again, both of them are possible. Are any faces opposite? So bow tie is opposite to the middle bar. So that's not. The circle is opposite to the arrow. And the half filled in is opposite to the cross. So they are all okay. So A and B cannot be eliminated simply by using method 1 and 2. So what should we do then? Well, let's open it up and see if we can find it. So if we open this one up, and I'm going to use the arrow, because there's only one arrow this time, that's fine. And so it has a bow tie shape on top of it. And it has a cross to the right of it. Okay, and so now we need to find this in our transformed net. So we go with arrow to be the middle. We go with the bow tie, and we can move that one from the top to be below it. And now what are we going to need? Well, we're going to need the cross to be on the right of it, because that's the only way we can translate it down. It's going to be to the right. So what do we do then? Once we rotate this, is this shape possible? Well, when I rotate it, I find that actually no, because the faces are in the wrong order this time. So is this possible? This is not possible, which is A is not the correct answer. So now let's check B. So if we look at B, I'm going to expand it again from the middle bar. That's the only one. So the middle bar is on top of it is a cross, and on the right of it is an up arrow. So let's try to find that. If we go from the middle bar in the net, we find that the arrow is below it, and we're definitely going to need the arrow. And we also need the cross. Now this is just one rotation down this time, nice and easy. And if we again tilt our heads, what do we find? Oh, actually, these two are the same when they are rotated. So that means that B is the correct cube. It's the only cube that can be made from this net. Okay, I think I have one more question for you guys. Now, this one's quite tricky. Why is it tricky? Because there's lots of arrows. Okay, and so what should we do in this case? Well, I can see that there's lots of arrows, but every single cube only has one circle. So when I expand the cubes, I'm only going to expand with the circle in the middle, because then I only need to transform my cube once to have the circle in the middle, and I can just compare all of them. Okay, so let's look at A. A, if it has a circle in the middle, the top face is pointing towards it, and the right face is also pointing towards it. In B, I can do the same thing. So it has a circle, and this time the top face is pointing away and the right face is pointing away. For C then, the circle face is on the top. So I'm going to have one face below it, which is pointing down, and one face to the right of it. Now, which way is this one pointing? If you think about flapping it up, this is also going to be pointing down. For D, it's going to be the same. So it's going to have the circle on the top, one face below it, and this time it's going to have one face pointing towards it. And E, finally, it's going to be opening with the face on the right. So we have a face on the right, which is the circle. We have one above it, which is pointing away. And we have the face on the left of it this time, which is pointing towards it. Okay, so now we've expanded all of our nets. Let me just label them again. A, B, C, D, and E. So what about it? What about when we transform our cube then? So sorry, I've switched the colors here. But when we transform our cube, we have the circle in the middle. We have one arrow pointing upwards, one arrow pointing downwards. And then we have an arrow to the right, and this time we're going to rotate it. So it's going to be facing down. And we have an arrow to the left. Again, this is going to be facing down. So let's have a look now. So can we find the net A in our transform net? Well, no, and not because I've rotated it 4 times, but I can see that A has 2 arrows pointing towards the circle. But how about in the transform net? There are no arrows pointing towards the circle. So that means A can't be correct. How about B? Let's do the same trick. B has 2 arrows that are pointing away from the circle. And I have no arrow, I have 2 arrows which are pointing away from the circle in my net. But remember, these are opposite. If you have a look in the blue net, they are actually opposite each other. So that means they can't be touching, which they would be in B. So these ones are also incorrect. Okay, what about C then? Well, if I look at it, circle's in the middle, the one to the right is going down, and the one below it is also going down. So C is the correct answer. So just for completeness, let's check D and E as well. So D has one pointing towards and one pointing away. So let's have a look. There's no arrows which are pointing towards D, towards the circle, sorry. So that means D is incorrect. And by a similar logic, E is also incorrect. Okay, so that's the last question I have for you today. Thank you very much for watching this recording. I hope you can join me later on this week when I'm going to be doing more non-verbal reasoning questions. I hope everybody had fun, and I'll see you soon. Bye-bye.